So this is my last video. I thought I'd give you a chance to do one more with a with a multiplicity of 3 on one of the factors. So maybe pause the video and try this one on your own. So we count the degree, or count the multiplicities. Count the multiplicities, we get 2 plus 3, and that's 5. And then the end behavior model, since A is positive, it's going to go up from left to right. Odd degree, A positive, goes up from left to right. And then next thing we want to do is, again, plot the X-intercepts. So the factor of X minus 2, so by now this should be pretty straightforward. X minus 2 as a factor means that 2 is an X-intercept, or 2 is a 0. X plus 4 as a factor, 1, 2, 3, 4. So negative 4 then would be a 0. And the end behavior model is going to start low and end high. So do that first. So just identify, again, the ends of the graph. And when you look at the first 0 of negative 4, so the first 0 of negative 4, right here, we're going to look right there at the multiplicity of the factor that corresponds to that 0. So the multiplicity is a 3. So if the multiplicity is a 3, it means we're going to have a squiggly right there at, let me see, make sure I get the right color. We're going to have a squiggly right there at that 0. Remember, okay, now understand this. When you do the squiggly, it doesn't go up like this and down and like that. Don't do that. Make sure that you identify the squiggly is flat right there. It's flat. So you're going to go up, and just like you're going to come back down, but you're not going to come back down. You're going to go up, and then you're going to go flat, like you're going to come back down. Instead of going back down, you go up. Oops, messed up on that. So that's that part. Then we're going to look at the next X-intercept of 2, and we have to get to here. So, but we're looking at the 2, and we're looking at the multiplicity. The multiplicity is a 2, so that's a good thing because we have to use our knowledge of that multiplicity. The multiplicity of 2, meaning we're going to touch the x-axis right there at 2. Again, it doesn't matter how high or low you go here. It doesn't matter how steep you put this. Just get the graph above and below the x-axis and the correct behavior at each of the x-intercepts. So the key is identifying your end behavior model and then knowing what to do at those with those multiplicities. Now, the con challenge problem. This one always is a challenge because we do so much with factored form, and then we go, what do we do when we don't have it factored? Well, if every one of the graphs that we have drawn have related to the factored form, then that would be your signal that you have to factor this polynomial. But I did want to point a couple things out. You can identify the degree and the end behavior model based on this being in standard form. This is standard form. Standard form. Some are factored form, which all the ones we've done up until now have been in factored form. This is standard form. The degree is just the highest power, so we learned that in one of the previous lessons. So the highest power is the degree when the polynomial is in standard form. When we look back here, the degree when it's in factored form, you just add the powers. So 2 plus 3 is 5. So it's different how you find the degree. End behavior model, we know A is negative. So we know that degree odd, A negative, means that the ends of the graph are going to go down from left to right. So I need some room here, so let me back up. And, oops, made a mistake there. Hold on, let me put this back in there. End behavior model. So we already know that, again, the degree is 3 and the end behavior model is going down from left to right. So if we have to factor, if we need factored form, then let's go ahead and factor. When you look at this polynomial, you should notice that we can factor out a common factor of x, but I really don't like my leading term to be negative. So I'm going to take the negative x out, and when I say leading term, what I mean is the leading term in the remaining polynomial. I don't want that to be negative. I want that to be a positive number right there. I want this guy right here inside the set of parentheses to be positive. So therefore, take out a negative x. And then when I take a negative x from a positive 4x squared, what I'm left with is negative 4x. and factoring out a negative x from the negative 4x, what I'm left with is positive 4. So if you're kind of struggling with that, understand that all you have to do is to visualize why we did that is just multiply it back out. And negative x times x squared, negative x times x squared is negative x cubed, check. Negative x times negative 4x is positive 4x squared. So just check. If you multiply it back out, you get what you started with. Let me make sure I don't back out too many of these guys. Alright, and then what we're left with is we still have this negative x on the outside, but now we have this polynomial that we need to factor. So we use the FOIL method for that. The factors of x squared are x and x. The factors of 4 are 2 and 2. And negative 2 and negative 2 add up to negative 4. So this would be the remaining factored form of the original polynomial that was in standard form. So now we have something that we hopefully by now are doing really well understanding how to graph. And here we have y equals, and so I changed the f of x to a y. And we see we have a degree of 3 again, so we can 1 plus 2 is 3. The end behavior model, a is negative. So same thing, same function, it's just factored form. X is a factor, that means that 0 is a 0. X minus 2 is a factor, so that means that 2 is also a 0. We know the graph starts high and ends low, so the first 0 of 0 has a multiplicity of 1, which means that the graph is going to go through the x-axis at 0. The next factor of x minus 2 has a multiplicity of 2. That means the graph is going to touch the x-axis at 2. And we matched our end behavior model with the correct behavior at the intercepts, and we are done.